In this video, we once again see how Kontext's model fuses images. When the Kontext large model was first open sourced, we placed the objects we wanted to integrate on a white background and then overlap them with images. So this is not a new approach. The main update this time is the improvement of a LoRA model, which enhances the probability, stability, and effectiveness of image blending. This is actually quite powerful in an open source workflow. There have been LoRA models capable of performing similar tasks before, but with lower probabilities. I personally really appreciate this model, so I'm sharing it with everyone. Then let's take a look at the workflow. I'm using RunningHub, the largest online rehabilitation AI platform worldwide. First of all, this process is definitely a Kontext workflow, and it's completely open source. The model combined with the LoRA model is not going to be discussed here. The main focus is on the image preprocessing mentioned earlier. We input one background image and then add one, two, or even more images that we want to blend into it. First, do background removal. If the automatic background removal isn't good enough, use CM2. If CM2 doesn't work well either, then do it manually. Then place it on a white background, crop the image, and bring it to our canvas. Before running the entire workflow, we first perform image preprocessing. Note that this section does not use the run button to start the preprocessing workflow before it. Using the load button allows us to run only the part before the canvas, and the part after the canvas will not be executed. We click to load, but there's no response because this location was run before. Update the seed and load again. This is image cropping. We can select the area we want to incorporate. After applying the crop, it will be input into our canvas. Let's adjust it to find the right position where we want to place it. So the images we want to blend in and the background being merged should follow certain perspective rules. Otherwise, the model will imagine them on its own. So when we want to place something, there will be some offset. After pre-processing the image, if you're running it online, my suggestion is to right-click and save the image again, then reload it. Then click Run to execute this part of the Kontext process. If we run it locally, we can just connect the two wires directly and send it straight into this part of the Kontext process so it can run. Why did you do that? If we need to run it online again, we might still have to go through the image adjustment process once more, making the entire workflow very inconvenient. Then we proceed to write the prompts, and the trigger words come from Old Yang's official introduction here. Blend it into the background. Personally, I think after triggering this, we could briefly describe what kind of scene it is. For example, here I have a rice cooker on the table. After the sampler finishes its work, the results come out. It can well preserve the details of our reference image. Then, the Kontext model sends the entire image into the latent space. If we do migration, maybe we just need to in-paint part of it, so the image fusion capability of Kontext model is quite high. Lighting can also be properly set up. The previous two versions of the model iterations weren't introduced. Instead, this focus was on the raw model. The point is to show that this workflow has already reached a usable state. The final point is about transferring details. In this category of flow, I've noticed a common issue when trying to recover details. Their position has shifted, so they may not blend well. We can only deal with situations where the alignment is completely wrong after blending. Navigate to RunningHub, click on AI, or click the link in the introduction to register and get 120 gigabytes. Log in daily to receive an additional 100 points. The corresponding AI workflow and one-click AI applications have been deployed online and can now be run and tested online. Finally, let's look at the results of my 3 blended versions. So the first one is a woman holding an axe. If you directly do the fusion using the converse model, it's actually not that easy. Without using a LoRA model, the similarity to the axe itself would drop, making it hard to interact with this hand in cases where similarity isn't lost. So after I found out about this LoRA model, I immediately tested it with this example. That's really good. The second result was a rice cooker. On the canvas, I cropped part of it because the original rice cooker didn't match the background's perspective. I cropped it so that the model could imagine the scene on its own. When you use it yourself, you can do some pre-processing to adjust the structure, and the probability will be very high. The third result is what we get after watching the entire video. When the angle difference between our fused image and the source image is not too large, it's basically a success. Your Kontext model already produces high-quality images, and increasing its size will make them even clearer. As for open source, this process is already quite good. If we compare it with a banana, this is what a banana can do. It's actually usable too. Even saying that I could take the image I pieced together from this canvas and directly put it into a banana to get results is possible. Let me tell you that bananas are completely closed source models. What we're sharing here is an entirely open source, free, and practical workflow. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. He brought down the prices of many popular models, such as V2, Kaling, and Wanxiang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.